All right, my friends. Now, this is the point where we talk about the probability for the first time. Now that we have defined the term event as a mathematical concept and events are defined as sets, we are going to define the probability of an event in mathematical definitions. So consider an experiment which has a sample space S. Therefore, we consider that this is a random experiment. And we are repeating these random experiments under exactly the same conditions. Okay, so let's give the simplest of the examples. Imagine the toss of a die. You are tossing a die repeatedly under exactly the same conditions. Basically, you have a board and you are throwing or tossing this die over that board. So you are basically providing these same conditions to toss the die. Now, we know the sample space of this experiment has 6 possible outcomes, integers from 1 to 6. Basically, this is a repetition of the same experiment and again and again and again, and we are observing the outcomes at each repetition of this experiment. Now, in this sample space, assume that we have defined an event E, and here this function NE is the number of times in the first n repetitions of the experiment that the event E occurs. So you are repeating the experiment for n times, and you are counting in how many experiments you have observed that the event E has occurred. So n is the number of total repetitions, and ne is the number of times in these repetitions that you have seen event E to occur. Now, the ratio between ne and n gives us an approximate idea about the occurrence likeliness of event E. So let's just say you have repeated this experiment 100 times, and in 30 of the experiments, event E has occurred. So if you divide 30 to 100, this value is going to be an approximation for the likeliness of occurrence for event E. Now, the probability, however, is defined in a different fashion. The probability is defined as the limit of this ratio. So we are looking at the ratio of the number of times that event E occurs among the number of repetitions. However, as n goes to infinity, as we repeat the experiment under exactly the same conditions for infinitely many times, then this ratio is going to converge to the probability of event E. Therefore, the qualitative explanation for this limit is the limiting proportion of time that E occurs. So what is probability for an event? It is the limiting proportion of time that E occurs. So limiting because we need to repeat this experiment infinitely many times. Proportion because we are looking at the ratio of the times that event E occurs over the number of repetitions. So imagine the example that we have given in the beginning of the video. We have an experiment, which is the toss of a single regular die, and the sample space contains 6 possible outcomes, assuming that this die is a fair die. Now, event E is defined as the upturned face to show an even number, and we have said that event E is the subset that contains the even values as the outcomes, 2, 4, and 6. Now, let's just say we are repeating this die toss experiment for 10,000 times. We are repeating and we are recording each outcome until all 10,000 experiments are performed. So the first experiment results with a 3, the second experiment results with a 5, so on and so forth. It goes like this: 1, 3, 6, 2, 1, until all 10,000 outcomes are recorded for 10,000 repetition of the experiments. And of course, we are not able to write every outcome here in the small page, but let's just say, for example, we have observed an even number in these outcomes for 5,026 times. Or in other words, in these 10,000 experiments, we have observed event E for 5,026 times. In other words, in the mathematical explanation, as we have defined in the previous page, since n is equal to 10,000, NE as a function, as a count of the number of times event E has occurred in 10,000 repetitions, is 5,026. And the ratio between 5,026 and 10,000 is just going to be an approximation for the probability, not exactly the probability itself, but the approximation of probability. And we can say that since out of 10,000 times, this event has occurred 5,026 times, this probability can be not exactly, but approximately 0.5026. But what is the actual probability? According to the frequentist perspective or frequentist definition on probability, the probability E is the limit of this ratio as the number of experiments or repetitions goes to infinity, which should be 1/2, because assuming that this die is a fair die, we know that the chance of seeing an even number is equal to the chance of seeing an odd number. So this is how we define the probability function according to the frequentist's perspective. Now, there are other definitions of probability function based on subjectivist perspective. However, in this course, we are going to assume the frequentist perspective to define the probability function. Now, the probability function is basically what? Now that we have understood it, first of all, a probability is only defined for events which are subsets of the sample space, right? So a probability is converting a subset of the sample space into a number within the unit interval. Because if you take this ratio will always be between 0 and 1, right? So if you take the ratio of the number of the events we observe in the number of repetitions, this value can always be between 0 and 1. Therefore, the probability is a function of an event which defines a quantitative value between 0 and 1 for the subsets of the sample space. And it only yields values within the unit interval between 0 and 1. So this interval is called the unit interval. The probability of an event quantifies its realization likeliness. So it basically measures the chance of occurrence. The probability is a measure that represents the chance of occurrence or realization likeliness. Now, if the probability of an event E is 0, this means this event will never ever occur. If the probability of an event is equal to 1, then we say this event will always occur, will definitely occur. At any repetition of the experiment, this event will definitely occur. If the probability of an event is between 0 and 1, the event E may or may not occur. So there's a chance that it may occur, but there's also a chance that it may not occur as well. And the possibility of an occurrence is going to be greater when the probability of an event is large. So if the probability of an event is much more closer to 1 compared to 0, in that case, the possibility of occurrence, the chance of occurrence is going to be greater. Now, of course, since we have defined a mathematical representation for the probability in the form of a function of the events, there will be some axioms that we need to believe about the probability function. These axioms are the probability axioms. But we are going to talk about these axioms in the next video.